Yeah, hi. My name's Jeff Eggleston. As a way of introduction, I am basically the chair for this session, and the session is auto provisioning for zVM accounts with Node.js and SMAPI, and it is going to be given by Ross Cruikshank from IBM. And what I'm going to do is hand it over to Ross. It's all yours, Ross.
Thank you, Jeff. Um, I'm a developer advocate, and I currently work with the IBM Z Explorer platform. So I create new content, I build the system with a small but elite team of experts in Z skills, trying to make things easy for people to get their hands on to try out various aspects of Z systems. And what we're going to talk about today is an aspect that we've been working on for the last 2 or 3 months, which is to introduce free hands-on permanent access to zVM systems, CMS environments, and build up skills for being able to navigate within zVM, but also to manage the hosting of Linux machines, virtual machines. So what I thought I'd do was just give you a quick recap of what zExplore is, in case you haven't heard of it. Some people know about Master of the Mainframe. This is kind of the son or nephew of Master of the Mainframe. Talk about customer demands for zVM skills, what the challenge we're trying to address here is. When I say the solution, it's just a solution. I'll talk about that in a little bit more detail. The things we learned as we were building it, the various options that were available that we had to discard, why we discarded them, those kind of things, sort of architectural decisions, and then where we're going next. So once we've got this mechanism in place, what will we begin to build out so that other people can pick up new skills and try things out? If you would like to, if you want to ask questions, just either post them in the chat and or wave a hand at Jeff and he'll open up for questions. So quick reminder, really, as IBM Z Explorer is the follow-on to Master the Mainframe, which was originally a 3 to 4 months every year since 2004 student challenge aimed at getting students to pick up the skills for mainframe. Very much started in the turn of the century, where people were worried about skills gap, with a generation of missing mainframers. Here we are 20 years later, still trying to address that, but with a much stronger, healthier mainframe market and perception, I think. So lots of people can join this now. It's not just students. So you've got hands-on environment for reskillers, so people who already know what they're doing but want to learn some of the things they never got to play with in their jobs, who can't access certain aspects of their environment because it's locked down. So if you work for a bank or an insurance company, you can come on zExplore and play around with things you couldn't get anywhere near on your home systems. We have students and student programs that link into it. So we have educators that use zExplore modules, and largely based around ZOS skills. That's kind of where we started from. And what we're doing now is adding in more components to make it a broader and deeper skill set than you could get with the Master of the Mainframe versions, which were reset every year. So for 6 to 9 months of the year, there was nothing. Then you had the contest, you learned fundamental skills, part of the contest, and then we shut it down and cleared it all out and did it again the next year with slightly different content. Now we have a continuous learning platform where you can keep adding to your skills. We add new content, we get contributions from products, from academia, who offer us ideas or content to host new challenges on the system. all very much geared to self-paced experiential learning. And to come out of that and to show that you've done this kind of thing, we give you digital badges. So the digital badging program we do with Credly, and that gives us a basics badge, which is called fundamentals and concepts, an advanced badge, and we've just recently introduced a badge called All-Star. And you'll see that we've got these challenges will tell you which badge they contribute to, or where they're essentials to fit into our badging program. We have this learning path, which is currently set up to be skill level based. So learn fundamentals and concepts, move on to advanced, and then you go into the extended, and the extended modules take you into the All-Star, which is someone who is kind of a jack of all trades, has tried lots of different aspects of working on a mainframe with traditional utilities and environments, but also modern tooling like Ansible, working with Go, Python, Node.js, trying to building COBOL, but running it in the Unix environment, accessing DB2 or files and so on like that. We have a separate channel that is defined for the ZTPF transaction development, and that's supported by ZTPF team itself. We also offer Linux on Z through the Linux One Community Cloud, and that lets people try out things like Docker running on System 390 images. And we do some machine learning as well. So you can try out Python, Keras, TensorFlow, generate open source deep learning machine learning models with Onyx and export them and bring them onto ZOS world. And do an awful lot with these open source languages and frameworks to bring people onto the platform who already have some skills, but are looking for ways to exploit mainframes better. So why are we doing things with VM? If everything was all ZOS and all the hype for the last 3 or 4 years since the COVID pandemic showed that there was all these kicks and couple batch programs running on mainframes that people had thought had died out in the 90s. What about VM? Well, our customers are kind of interested in doing virtualization. We're hearing the story from IBM and our partners about sustainability, about total cost of ownership, cost of management, consolidating workloads onto mainframes, particularly the Linux One platforms. There's some heavy nudging coming from IBM as to bring your workload closer to where your customer data is rather than pushing it out to the cloud. Work with a hybrid model. So they're discovering that, yeah, it's great to have a plan to bring lots of Linux workload onto a mainframe, but you're going to need some skills to manage the hypervisor. And you've got a choice of KVM or zVM. And if you've got any other mainframe operating systems, you've probably done some work with zVM. And it's got an even larger skills gap in the sense that the product itself didn't get a lot of love for a while. So it didn't change. It kind of drifted into the background. And a lot of the tooling that was built for it has migrated off to other environments. So there's no kind of organic skills gap being addressed in the way that ZOS has been benefiting from for the last 5 to 10 years. So they want to get hands-on with CMS. A lot of people don't even know what CMS is nowadays. Work with things like Xedit, work with CP, be able to manage the directories on VM to be able to create virtual machines. And ultimately what they want to do is build and manage Linux guest machines. We can't offer something that makes it a full experience of being able to operate multiple Linux machines, but what we can do is give people the ability to create systems, see how they work, understand what's going on with the VMCP environment, with using CMS and some of the service machines to manage the environment that makes Linux VMs work and be able to monitor and provision them. So the challenge for us was, well, where can customers get these skills? If you look at Z Trial, where you might think you might be able to get your hands on a free zVM environment, there's nothing there. There's no kind of short-term tryout VM. There are some courses that IBM offers. We can do them as a boot camp, and it might be way through partners, but those are a full week's worth of boot camping. You can also do some of the things like wildfire events with the Washington System Center if you're in North America. Maybe you do something with Montpellier in Europe, but essentially those are kind of sit down and work through a day or two, and then they're gone. InSkill, of course, offers great courses, lots of information about managing VM and CMS and setting up all the environments and monitoring, but it offers very limited hands-on options. It's all assuming you've either got your own VM environment, or you can work through the class materials and have a little bit of simulated. But it's not free. You need to have a subscription. Usually InSkill is an enterprise subscription account. So what we're looking at, the alternative then is getting on the job training if you happen to have zVM in-house if you're already employed. But who's going to mentor you? Quite often those people are, much like the ZOS world, they're getting towards the end of their careers, and don't necessarily have the time to do some mentoring and bring someone on, if you like. So what we're looking to do is try and get that self determined education going. So there's some education links available for VM, all of which would be great if you have your own VM CMS environment to play with. So what we wanted was to provide a free, always-on access to zVM. We can't use third-party software because the hosting for Z Explorer is not licensed to have third-party products. So it has to be basically free or IBM provided to make it work. We want to be able to deploy CMS accounts on demand. So when a user in our Z Explorer system reaches a particular level or completes a challenge that makes them eligible to get into zVM, we want to be able to provision an account automatically, tell them how to log in, and off they go. In the next month or two, we'll be in the process of also being able to provision Linux VMs on demand for those advanced users who have been through the basics of how to operate CMS and CP. We want to make it so that we could synchronize passwords. So once you're on the system, you get a user ID and a password that's posted on ZOS, and zVM would stay either synchronized or actually use the same identity mechanism, so that we don't have to have multiple user IDs and passwords. We're using the current version of zVM that came out over the last year or so. zVM, unfortunately, most of what it needs is still 3270 based. It doesn't have the equivalent of something like ZOSMF to be able to dig into the mini disks and so on. So what we're looking for was a way to get around that. And we have to make it so that it's essentially self-managing, because there's only a small team of us that can look after it. So we looked at some of the technology options. VM comes with directories. That's how the virtual machines are defined, and there's an optional product from IBM called Dermate, which provides some service machines that can allow you to um, configure virtual machines, update the settings on them, assign new user rights, and so on, and create user profiles. We looked at using RACF as the security overlay for managing access to various resources on the system. And then there's a variety of different tools that come up for enabling provisioning of accounts and machines. Wave, Cloud Connector, current IBM Cloud Infrastructure Center, and the Open Mainframe project, Phelon project, which provides another service layer. And then what would we do if we had to roll our own kind of thing? Because we don't need the ability to do everything. We just need the ability to do simple account provisioning, password resets, and so on. So all those services make use of SMAPI, the Systems Management API for VM, which is a set of machines, virtual machines that run under VM. Provision them, they all auto log so that they look after an interface that can then drive Dermate or RACF for creating and managing access to resources. It looked like it would be something similar to ZOS for the ZOS, but it's very, very different. Works very differently, has very different things that it can do. So for Dermate, our choices were kind of straightforward. It's pretty much in the box. Most customers have it installed. It provides the wrapper around those the directory, the user directory, and we didn't have to do anything different from most of the virtual machine VM virtual machines that we bring up, because we always provision Dermate from it, so that was relatively straightforward. RACF, missed the T off Dermate. Dermate is an extra. Sorry, RACF is an extra on top of Dermate. It takes over a lot of things like managing access rights to resources. It redefines things. It takes over password control. We thought about doing it was being able to synchronize with our ZOS RACF. Unfortunately, our choice of moving to zVM 7.3 meant that the shared RACF support had been taken out. So rather than creating another RACF and having all the baggage that goes with creating this RACF overlay on things, we thought we'd leave that out for the moment. So far, we don't need it, and we'll keep it out the way if we can. Nothing wrong with RACF, just doesn't meet the needs of our specific system requirements. We looked at zVM Wave, which is product IBM acquired maybe 10 years ago for managing lots of VMs. It needs the SMAPI service in place, but it needs a whole bunch of extra tooling. It's also no longer available. Discovered that. So it's now gone to a company called Logon Software. So we can't use it because it would involve third-party licensing. So that went down the toilet. The next one we looked at was the IBM Cloud Connector for zVM, which was built so that you could do provisioning with things like Terraform, cloud provisioning tooling to be able to build VMs on demand. And again, it uses SMAPI, but unfortunately, it requires you to build another virtual machine of your own, so it doesn't come with one. But it has all the functionality we would need, just a little bit of extra admin to make it work. And then we discovered that it's no longer supported either. It's been turned into the IBM Cloud Infrastructure Center, which is even bigger, has a much larger footprint. It has a whole load of microservices built on top of it. It's got lots of high availability and performance management and stuff, lots of things we do not need to be able to set all this up. And that in itself would have had a bit of a burden for our team to manage. So we were thinking we've got this little nut we want to be able to look after, which is just create CMS machines and password resets. And this was a massive hammer that we didn't want to be getting involved with. So that one then went out the window. We looked at then Phelong, which is the follow-on to the IBM Cloud Connector. Once it was open sourced, it's free, it's available. It does require Linux VM, and it's very much geared towards the creation and maintenance of Linux machines. And that would be great for when we want to do Linux machines, but it doesn't have a lot of functionality readily exposed for managing CMS, user directory entries, and so on. So, okay, that takes us into our last option, which is to roll our own. Choose to make it so that it does just sufficiently what we need. It would be free, other than our maintenance and operations costs. We don't need a Linux machine to run it because we already run things for IBM Z Explorer on the cloud. We run things on ZOS. We run things in USS. So we had a lot of choices of where we could put an integration layer. When I looked into what the API was, it turns out that it's essentially a bunch of text messages, almost in control block format, but serialized and then sent over raw sockets interface, which took us back to, well, that's where things like Phenon came from, was a way to try and mask the raw sockets interface for this. But with a little bit of experimentation, we were able to drive the system using what I call my golden hammer, which is Node-RED. If you don't know Node-RED, don't know Node-RED, get in touch or go and have a look. Fantastic flow-based programming tool that sits on top of a Node.js runtime. And it led us to a solution, not the best solution, but it certainly worked for us to be able to build this. Brought in a couple of people to help me. One is Justice, who's based in the Washington System Center on the East Coast of the States. I mentioned them earlier. They run these wildfire courses and they do specialist training for managing VM and managing Linux on VM. So he's a specialist in that area. He volunteered to help me build a model that we could try out and see if we could get it to work. And then Clayton, who works in the Dallas ISV Center, which is where the Z Explorer platform is hosted, stepped in to be able to create the kind of production version for us. But without those two guys, I would never have been able to make this work. Watch out for them. I think they're going to be talking at the zVM workshop, or certainly be around the zVM workshop in June, July time. And they also do talks at things like Share and GSE. So we did a 3-stage build. First phase was Justice doing all the work with his mentor, Richard, helping out. We built a new machine, zVM machine from scratch. A new in our RL we created another VM host, if you like, to run these mini machines. He set up with Domain and RACF because that's kind of what they did by their off-the-shelf models. Installed and configured SMAPI. He created the prototypes for user accounts and mini disks. And then we set about proving the SMAPI interface using Node.js and its sockets support with Node-RED. And then we found that there were some constraints of the way that RACF worked. And there was some additional integration needed to make SMAPI work. And then we lost some functionality for what we wanted to be able to do. So the next step was to take what we learned, put it onto the Dallas ISV system, where we have Clayton doing the build, Justice helping him out. We did Domain, but with no RACF, set up SMAPI, got the prototypes all implemented, essentially copied from what had been done in Washington. And then we just pointed the Node-RED integration layer to the new SMAPI server on its different IP address, and off we went, provisioning accounts. So what happens now is when someone does a challenge in our zVM channel, they complete their zVM 0 module. I've got less than lines of Node.js. That's not what I meant. I'll show you what that means in a second. zVM gets completed, and we then go and provision an account. So the next challenge they get is go and log on to your CMS machine, and it's been provisioned while they've been just navigating the learning platform. So everything happens through the browser or VS Code normally. To get onto zVM, it's got to go on through 3270. There's no other way to get into CMS these days as yet. So we manage that through this infrastructure, and we're running both ZOS, zVM, and another Linux partition to make that all hang together. So we use this kind of layout. There you go, the structure for it. So we'll run lots of CMSs, talk to the system through SMAPI, and we will now, in the next month or two, as I mentioned, start being able to provision Linux machines for users to build the experience of defining directory entries, IPLing the machines, checking out the status of the machines, looking at performance, and so on. So this, I mentioned Node-RED. Node-RED is this flow-based programming tool. It doesn't generate code. It is actually the code. Each of these little nodes is existing code, just a little form to configure a flow of data through them. And this is essentially the whole integration layer to talk to the SMAPI provisioning system. Top half looks at generating a SMAPI request. So it's to package up what we want to be able to do and convert that into that serialized TCP socket packet, punch it across sockets, wait for responses, and we always get 2 responses from a good operation in SMAPI. One to acknowledge that it's received the request, and then another one that contains sends a correlation ID, and then the next one is the actual response. So we then parse the response, and that lets us make that part of our own API service that we can expose then to other parts of our platform. The data we get back is very much raw buffers, and it's all length value type structure. So we got to decode the length of each, and it's all run length encoded. So we have to figure out where we are in the block and which kind of object we're processing to know where the length fields are, where the character fields are, where there's binary data, that kind of thing. Parse it out. And then that gives us the ability to create this kind of state machine on the bottom, which is for provisioning new accounts. We can also use it for updating user passwords. When the ZOS password changes, we can just do an update and pass that through. The top flow is the kind of path of least resistance, which is just the password reset. The other ones come down, and we run a cycle where the user account gets created using the image create action that's defined in the SMAPI API. If that works, we roll around again with the next action, was to set their password, which is synchronized with we securely store the user's ZOS password so it can be synchronized across. That all works. We then circle around again with the next step in the flow, which is to do the disk copy, and that copies the prototype for their CMS kind of home drive, the 191 mini disk. So it's where they can run their own applications, store their own files, and so on. So it's a little bit like DOS. where you've got like an A drive or an A disk. That's your 191 disk, usually called A, and then up to 25 other disks, because there's all those letters left in the alphabet, where you can add more disks. So this creates their own, and then once the machine is defined, they can then IPL that machine. It's defined to auto log, so when they try and log on, it'll IPL their CMS machine for them. And after a lot of messing around, it turned out that actually the code to make this work, although it's all implemented in C, if you look at Phelong and its adapter code, there's quite a simple way of doing this with Node.js and just building buffers. So we created a little bit of a function here for packaging the SMAPI requests. You send in an array that contains all the parameters you want to send across and what kind of action it is you're invoking, and this will package it up and set all the length bytes appropriately, all the length prefixes appropriately, to send the message across to SMAPI. SMAPI then talks to Dermate and gets the results. That might be define the user directory, create the mini disk from prototype, set the password, query what things have gone on, and then we have to navigate our way back through the returned codes and responses to work out, did it work? If it didn't work, was it bad? Like, did we try and create a user ID that was already there? Did we try and set a password on our user account that doesn't exist? That kind of thing. Convert those into meaningful responses that we can then handle in our integration layer. So what we learned on the way, zVM security was the user directory and Dermate. We get user classes. We get the ability to have logon rights to run across different machines. So you can log on to another user as long as you're authorized to do so with your account, which means you can manage virtual machines. Those machines don't even have to have the ability to be logged on their own. You have to log on as someone else. We can handle password management. We can do sharing of disks, which means we can create little volumes and make them share across different accounts as read-only reference data. So almost like a read-only PDS on z/OS. So we can use those for storing reference information, challenge information, documentation, that kind of thing. RACFVM, it's very much based on RACF for z/OS. It uses the TSO commands. It always has looked like a port of the TSO interface to RACF. It has a lot of stuff that gets in the way of Dermate, and would also then have broken what needs to happen with SMAPI. We'd have to have done some additional work to make that function the way we need it to, so we drop that out. So no RACF. Currently, what we do is we build the mini disks, the VM definitions using these user directories. So this is all with the stuff that the users will get to see and understand how virtual machines are defined, with their ability to auto log, whether they have what kind of machine they're going to be emulating, their virtual spools and consoles and so on, so that they can intercommunicate, and then which of those shared disks they need to map when they come up, so that they can access TCP/IP, or so that they can run particular programs like ISPF. If you wanted to do that from the start, you could add the links into the machine definition. And then we have user definitions, which have less of the stuff about IUCV, so they're not running as service machines. You can see I've got this user ID has not just a G on the top there, but has A, B, C, D, E, F. They have a whole load of user classes, so they can define more, they have more rights onto the system. So that's the kind of thing that they can then work with. In the background, we're running the virtual machine. So from a CMS environment, you can see what's running that makes SMAPI work. So there's a number of virtual machines. TCP/IP is obviously needs to be there on the machine on the VM itself to make it work. But the other ones, the VSM request services, so you can have IUCV or Internet Protocol, which is the VSM Rec in. VSM Rec I6 is IP version 6 support. And then we have the SMAPI service layers that do various bits and pieces to spread the work around. There's a short type requests and long type requests for disk provisioning or migration or user directory integration or management. And then we have Dermate that is sitting around waiting for those requests to manage the user directory. Currently, the system not too busy at the moment. To get onto the zVM level to be able to access zVM, you've got to get through at least the advanced level on zExplore, and then you have free access to VM from there. So once we'd done everything that we needed to do, it came down to we only needed 3 of the actions in SMAPI to make it work. We want to create images using Dermate. That's what the DM suffix means there. Use the Dermate image creation. We want to do password set or reset. It's the same thing. Within the Dermate user directory services. And then we would like to be able to copy what's called a prototype disk, where we've defined a basic A disk for the users to have, which includes a profile, which when they start up can run commands for them to get going straight away. So when they get started, they've got a disk that's ready to use, and they can start building and messing around with files and editors and so on. What we don't do currently is destroy those things. We've been in the process of getting people onto the system. As the resources start to get a little bit stressed, then we'll look for opportunities to remove people who haven't been active for a while, so we can deactivate accounts. We'll be able to delete the users, and we'll be able to delete their mini disks if we need to later on. That gives us really very simple integrations, which we'll add over time. But this is essentially the entire integration that we have added on to zExplore to make it possible to get a VM instance up and running. We get the user ID from the current user in the membership platform. From that, we can get their stored mainframe IDs and passwords. We can then pass it across to this that little state machine that goes and provisions their account. All goes well. We update their profile with when their zVM goes active, and that adds them into a group, which lets us know who's working on zVM and when they started. And we can then offer them new services and new challenges based on knowing they already have a VM system to play with. Or we throw out an error and say, well, that didn't work. That's pretty much it. Then we had to add the password sync functionality, which was when we go to create a user ID, modify a mainframe user ID with the new password that we usually generate for them, so we don't get people creating passwords and forgetting them. We allow them to be recovered if they need to. We just had to add on that little extra step there that said if we have an active zVM account, then if the password on the ZOS changes, then take the same password and apply it to the VM. And so 3 lines of code change meant we could do password sync whenever we needed to. So that's now been running for the last 5 or 6 months. Sorry, 3 to 4 months. And over the next 3 to 4 months, we'll be bringing in the ability to say, you're getting a Linux, you're getting a badge, We would like to be able to offer people the ability to create their own mini Linux. It's not going to be very big. It's not going to have you're not going to be able to host applications on it or anything like that. But it'll give you the ability to fire up a Linux virtual machine using CP and the VM environment. It'll use DHCP, so we're going to be able to spin them up rapidly. We don't have to configure a lot of the networking. It'll all be done dynamically. One of the things that the tools like the Cloud Infrastructure Center don't really offer is a way to get to those consoles of your Linux machines unless things break. And what we would like to do is give people the experience of using it from the start so they know what it's like. There are some limitations on how you can talk to the Linux hosts through that console. So we try and give people the experience of doing that so they'll know what it looks like. And then we'll be able to then enable SSH login from the outside world through to their personal Linux machines. Once that's all in place, we can then start to revisit how we can offer badges. We used to offer badges in the days of Bill Bittner. I think we did kind of VM workshop badges, and they've drifted away. There are some badges available from Interskill that you can pick up. They're mainly about administration. What we'd like to be able to do is offer this kind of fundamentals badge. So that's in process, and we'd hope to have badges available in time for the VM workshop at the end of June, and then available to everybody for through Credly over the summer. If you've got ideas for what you would like to see available, a few things you've always wanted to be able to do with zVM and thought, well, I can't do it because my company won't let me do it. They're not going to spend the time for just one person to try. Think of it in terms of what if there were hundreds of people that were potential candidates to try your little idea. Let us know, and we'll see if we can get it into the platform. So to wrap up, last things, getting towards the end of the session. Quick recap on zExplore. So you've got an idea what it was. If you need to know more, go to ibm.biz/IBM-Z-XPLORE, IBM-zExplore. And we looked at where the customer demand had come from to try and get this going, and what drove me to make it possible, how we addressed that challenge, looking at all the different options that we could that were essentially free options, but had their various costs for management and infrastructure that went with them. We have a solution that's in place now, and we can grow that relatively straightforwardly, but it will require custom code. But the vast majority of the solutions that looked like they needed to, that we could have used it from elsewhere, all would have had customization anyway to be able to build the workflows and the templates that you need. And what's next is our zVM and anything else that people want to try. Let's have a look at the chat room and see if there's any questions from anyone.
There are no questions, Ross, but I have a few if you don't mind.
Yes, fire away.
So I've actually found this very good in terms of dealing with the zVM skills. And sort of the question I have is, can you give a sort of rough feel on getting somebody trained up? What sort of length of time and how long it would actually take?
So the idea that we've got with these is there were a series of workshops that have been run internally with IBM, and also some kind of hands-on workshops that ran at Share over the years, and they are geared really for within an afternoon.
Wow.
You should be able to see CMS is a tiny operating system.
Yes. Yeah.
It's a lot like DOS now. Unfortunately, in the old days, that was, well, DOS, so you'll be able to use VM. Lots of people don't know DOS so much anymore. But the idea is you should be able to get familiar with zVM and the CMS environment particularly within 2 or 3 hours, and be comfortable with it. We take you through it's all full screen edits with Xedit. So there's a couple of challenges. So there's essentially maybe a day's worth of just poking around. We give you some things to do, things to fix, do some investigation, learn how to do linking and then accessing shared service disks like TCP. You don't have TCP IP to start with, so how do you get it? You have to link to TCP maint. You have to access it as one of your 26 drive letters, if you like. And then you can use TCP services, right? And then we get you to locate files on other disks, run different commands. So yeah, within a day, people can get familiar enough with CMS to be dangerous, and discover things like CP is in there as another command level, where you can talk much more closer to the machine level, if you like.
Right.
We haven't done much in the application development. We did a little bit of Rex. We also do Rex on ZOS. So it's a little bit of Rex programming just to give you the idea that you can create a script quickly and easily, and it's the standard scripting tool for certainly for CMS. There is no Python that runs natively on CMS, and the other old exec languages are really hardly anyone does anything with those anymore. So we'll give you a bit of a feel for running with Rex. Some of the challenges we offer use compiled Rex. So yeah, it's a day.
Oh, wow.
It's not a complicated environment, just to get you so that you can be reasonably comfortable and dangerous. So you know roughly what to do. If someone said, link this disk, find this program, run the code. If you want to get more into how do you find out about your environment, how do you interrogate your environment, there's one of the challenges takes you into CP, so you can then start to query the machine, query what's going on. So that that view back here,
Yeah.
that one,
Yeah.
so that kind of thing. How do you see who's logged on the machine? It's the equivalent of using SDSF. There isn't really an equivalent of SDSF, but you can run commands which would produce the same kind of information, like who's on the machine, then find out a bit more detail about them. You can see what services are running. You generally don't have lots of tasks running because you tend to be a single tasking environment.
Yeah.
But yeah, within a day, you can get confidence to be able to play with it. And then we add those extra things on, which are the next phase, which is, all right, so now create yourself a virtual machine, IPL the virtual machine, how will you know where it's running, those kind of things. So we're in the process of doing that. And then it'll look more like a kind of zVM environment that people would be moving into, or maybe already have, where there's lots of Linux consolidation going on, or building new applications, new ISV applications that are natively hosted on Linux,
Okay.
under VM.
And then I take it once they've set it all up, how long do they have available to access, to go back and learn or what have you? Is there a time set?
Currently forever. So this is different from things like Z trials or our ZVA environment that we spin up for events. This is part of the Z Explorer package, if you like. So
Right.
you get ZOS, not for life, but for as long as our system runs, right? You can access ZOS, and once you've defined your CMS machine, then you have CMS. There's I have to say, there's probably not that much utility in it in itself.
Yeah.
unless you also then want to learn things like assembler programming or Rex programming. But particularly, we're taking it more down the lines of being able to manage the virtual machines or understanding what's going on in a management environment. So this is how these things work under the covers. And if you have IBM Cloud Infrastructure Center, for example, or Wave, the way they work is what's happening underneath the covers. And this shows you what's under the covers, and you'll understand the mechanisms of the machine.
Okay, I appreciate it. To be honest with you, I've been very impressed with what you said, and I'd like to certainly thank you for your time. Fantastic presentation. I actually got an awful lot out of it. And what I'd like to do is finish off on your last foil by
Okay.
saying, look, feedback's important to this presentation and to the the GSE community, because we analyze the feedback to actually decide what presentations we give in the future. So if you could put feedback, that'd be good. The code is AF, and the easy way to get to it is to go on to build your own agenda and just click on the link for this session. So unless you've got any other comments, Ross.
No, thank you very much for the
Okay.
opportunity to
So,
waffle about the fun we've had playing with SMAPI, learning all about it.
absolutely, and I pronounced it wrong as well. So there we go. Snappy. I'm pleased I can actually say that right now. So there we go. So I'm going to bring it to a conclusion, and thank you once again, Ross.
Very welcome. Thank you.
All right. Cheers.
Bye, everyone.